Update video 2 of 3 of our alum crystals. Let's take a quick look at our alum crystals. Here they are. You can see that there are literally no alum crystals. Shape, unattainable. Size, 0, not seen by the human eye. Quantity, 0 as well. Now, this could be due to a lot of factors, such as there's a high amount of humidity in the air, making it hard for the water to evaporate. But it's most likely due to the fact that I remade this solution yesterday. So there's basically no chance of anything growing. Sorry. In case you wanted to see a close-up of the seemingly empty vial, here is my current alum vial. You can see that there are no crystals, again, because I remade this yesterday. Now, I'm sure you're all wondering, yeah, Catherine, alum, that's cool. I mean, maybe not actually that cool because there's no alum crystals growing there, but what was the percent yield of your initial alum? And I'm really glad you asked. Let me run you through the process of calculating percent yield. First, you need to know the total initial mass of the aluminum we used, which was 1.02 grams of aluminum. Then, we multiplied that by 0.985%, because aluminum foil is only actually 98.5% actual aluminum. From that, we gathered that there are 1.0047 grams of aluminum in aluminum foil. Then, we figured out the actual mass of alum that we gathered, which is 17.84 grams. In order to determine the percent yield, we had to figure out how many moles of aluminum there were in both of these masses. To do this, we had to use the molar mass of both alum and aluminum. The molar mass of aluminum is 26.9815 grams per mole, and the molar mass of alum is 474.3884 grams per mole. In order to figure out the number of moles of both, we had to divide the previously found masses by their molar masses. The formula for percent yield is measured value over theoretical value. The theoretical value for our percent yield is the initial number of moles of aluminum in the solution because we're assuming that every mole of aluminum in the initial mass ended up in the final mass of alum. However, this is not true. You can see that our percent yield is actually 99.47%, which is very, very close, but there is some missing. Now, I'm sure there are at least a few dedicated viewers out there who want to know where the extra moles of aluminum went. There are a few possible places where it could have gone. The first is that we actually filtered the alum a few times in an attempt to clean it and wash away any impurities. And because the alum was put on this filter paper so many times, it's possible that when it was lifted off of the filter paper to be masked, that we lost a good amount of the alum in the filter paper as residue. And another big possible sink is that my lab partner and I actually spilled some of our initial aluminum solution. So some of the aluminum solution actually ended up on our lab counter before it could even be put in an ice bath to be turned into alum. And as such, the percent yield isn't exactly 100%. Not every mole of aluminum made it, which is honestly devastating, but I feel like Laurel will forgive us. At least I hope she'll forgive us. The interrupting my video is Oh no.
There, yeah.